Section 4.2, number 53, we had to find the equation of this graph, given that the equation is in the form of a cosecant of bt. And I can see that it does look like the general shape of the cosecant graph. So I just have to check out what a and b is. So to find a, let's find a first. To find a is going to be the maximum and the minimum. So remember our sine function was the inverse, and it had the maximums at 1 and -1, unless a was not 1 or -1, in which case whatever a was our max and our min. Same with our cosecant function. So our max and mins land at a and -a. So that on this graph looks like we're counting by 2's based on that scale. So that looks like a 2 and a looks like there's a little mistake here. Okay, fix that scale a little to match what's in the book. So now I can see that the scale is, okay, so our minimum is now at 2 and -2. So a equals 2, and I know a is positive because it's not flipped. I have the between 0 and the first period here in the reference rectangle, it's going up, just like the sign would with a is a positive number. So a is a positive 2. And then to find b, that we need to look at the period. So I know that b equals 2 pi divided by the, well, kind of reversed. I know that the period is that divided by b, which implies that b equals 2 pi divided by the period. So let's look at what the period is. So the period, so I have one up and one down, and it looks like the period is 2/5. So when I plug that in for b, I get 2 pi divided by 2/5. And to stretch that out a little, I'm going to put them both as a fraction and do a division of fractions, which means I put that first one over 1 and then flip the second and multiply. And I get my 2's will cancel, and I'm left with 5 pi for b. So I get b equals 5 pi. So my final equation is going to be y equals 2 cosecant 5 pi t, where the 2 is the a and the 5 pi is that b.